In this section, we'll start looking at solving systems of equations with three variables. Now, the first step to solving this system is going to be to choose which variable we want to eliminate. When we look at these three equations, we have an x, a 2x, and a 2x. We have a negative 2y, a negative y, and a positive 2y. And we have a 3z, a negative 2z, and a negative z. There really isn't much difference between the x's and the y's. We probably don't want to eliminate the z's because at some point we're going to have to multiply one of the equations or both of the equations to be able to solve this. So the best choice is to pick either the 2x or the 2y. We'll go ahead and we'll start with the x's. Now, once you've decided which variable you want to eliminate, the second step is to pick which of the two equations you want to eliminate that variable from. So we'll go ahead and pick the second and the third equation because those are going to be the easiest to get rid of the x's from. So we're going to start with these two here. So we're going to rewrite 2x minus y minus 2z equals 5. Then we're also going to rewrite 2x plus 2y minus z equals 4. Now, in order to eliminate the x's, we have to make one of those x's negative. So we'll go ahead and do that to the bottom equation. We're going to multiply through a negative or a negative 1. So that's then going to give us negative 2x minus 2y plus z equals negative 4. Now, at this point, I would go ahead and cross out this equation just so we don't get confused and end up getting our arithmetic wrong. So go ahead and put a line under there and do your subtraction. 2x minus 2x, that's going to cancel out. Negative y minus 2y will give us negative 3y, and negative 2z plus z will give us negative z. That's going to be then equal to 1. We're going to leave this alone for just a minute and we'll come back to it. The next step in the process is we've got to choose the first equation that we didn't use and then one of the other two equations that we have already used. So why don't we go ahead and take the first equation and the second equation. We're going to rewrite those. So we'll end up with x minus 2y plus 3z equals 12. We'll also have 2x minus y minus 2z equals 5. Now on this one, in order to eliminate the x, we're going to have to multiply the top one, and it would be best to multiply the top one by a negative 2. That will give us a negative 2x. That way we can eliminate the x's. So go ahead and put your parentheses around, again, because we're using distributive property across the entire equation, and that's going to become negative 2x, and then negative 2 times negative 2y is positive 4y. Negative 2 times 3z is negative 6z, and that's going to be equal to negative 24. Cross out this equation because we're not going to use it now. Then we're going to go ahead and subtract what we've got here. So 2x minus 2x is going to cancel out. Negative y plus 4y is 3y, and negative 2z minus 6z is negative 8z. That's going to be set equal to negative 19. At this point, we now have two equations with two variables. So we're going to line these up just like we would, or just like we have with previously doing two variable elimination. So 3y minus z equals 1. We're then going to bring this down underneath it. 3y minus 8z equals negative 19. So the next step in our process is to decide which of these two variables are we going to eliminate. Because we've got a negative 3y and a positive 3y, the obvious choice is to then eliminate the y. So let's go ahead and do that. Negative 3y plus 3y is going to cancel out. Negative z minus 8z is going to give us negative 9z, and that's going to be equal to negative 18. Divide out the negative 9 from both sides, and we end up with z equals 2. So now we have one of our solutions. We know that z equals 2, but we've still got to find out x and we've got to find y. So the next variable we're going to find is y, because we've already got these equations here. Okay? So we're going to take the z that we know, which is 2, and we're going to plug it back into one of these two equations. It's really up to you. The easier one is probably going to be this one here. So we'll rewrite this as negative 3y minus the quantity of 2 equals 1. Okay, so negative times the quantity of 2 is just negative 2. So we need to add 2 to this side and add 2 to this side. That's going to help us to isolate the negative 3y. So we end up with negative 3y equals 3. Divide out your negative 3, and you end up with y equals negative 1. At this point, we have the y, and we know the z. So we're going to take these two now and plug them back into one of the original 3 equations. We'll go ahead and choose the first equation because x is already isolated on that one, or x does not have a coefficient on that one. So we're going to rewrite this as x minus 2, y is equal to negative 1, and then plus 3, z was equal to 2, and then set that equal to 12. So now we just go ahead and run our math through. X, negative 2 times negative 1 is positive 2. 3 times 2 is positive 6, and that's equal to 12. So x plus 8 is equal to 12, and subtract our 8, and we're going to end up with x equals 4. So at this point, our solution looks to be 4, negative 1, and 2. Remember to write your solution as an ordered triple. That's in x, y, z form. The last step, once we've gotten our solution, is to go back and check our work. So we're going to take one of the 3 variable equations that we didn't use in the last one, and we're going to plug our values into that. So we'll take this one right here, the middle one. So 2 times 4 minus the quantity negative 1 minus 2 times 2, and that's supposed to be equal to 5. So 2 times 4 is 8. Negative 1 times negative 1 is positive 1. Negative 2 times 2 is negative 4, and that's supposed to be equal to 5. So 8 plus 1 is 9, minus 4 is 5. So we get 5 equals 5. And we now know that our solution of 4, negative 1, 2 is correct.